All right, so we're going to be talking about series today. So a series is very similar to a sequence. In fact, it's just the sum of a sequence. Sum of a sequence. So remember, a sequence is a list of terms. A series is the sum of that sequence. So with plus signs in between. Now, of course, if some of the numbers are negative, we'll be subtracting because we'd be adding a negative. So we have some equations that are going to help us find the sums of these series. So they look like this. S of n, this is for arithmetic series. S of n is n over 2a plus n minus 1 times d. Okay, and all these letters represent the same things as they did before. Now there's an alternate equation we can also use. Sn is n over 2 times a plus tn. Okay, so S of n in these equations represents the sum of the first n terms. Okay, so our sequences can go forever and ever and ever. So when we want to add them up, usually we just say, okay, we want to add up the first so many terms, the first n number of terms. T of n then is the value, not just of the term n, but it's the value of the last term. All right, so let's see how we can use these equations in practice and look at a series. So this is what a series looks like. So instead of being separated by commas, we just use the signs in front to add or subtract up the terms. So we have -7 plus -5 plus -3, etc. So for this series, we want to find S11. So a couple things to note here is that A, we can tell right away, is the value of the first term. So A is -7. And it looks like from one term to the next, we're adding 2 each time. So that'd be our D value. And it wants us to find S11. So we know N. N is 11. So with this information, we know it looks like we want to use the first equation. We do not know the value of the last of term 11. So we can't use the second equation. So let's set it up. So S11 is equal to N over 2. So 11 over 2. Times 2 times a, so 2 times -7, plus n minus 1, or 11 minus 1, times d, which is 2. Okay, so let's do some calculations here. So 11 over 2 we can just leave as a fraction, or you can write it as 5.5 times, and then 2 times -7 is -14. Here we're going to have 11 minus 1 is 10, times 2 is 20, so plus 20. And we can finish bad math here, right? So we want to add in the brackets first. So we get -14 plus 26 times 5.5. You can use your calculator for that. Gives us 33. So S11 is 33. Okay, so let's take a look at the second example. It says the sum of the 100-term arithmetic series, or find the sum of the 100-term arithmetic series that starts with 5 and ends with 700. Okay, so it's 100 terms, so it's telling us n. N is 100. It says it starts with 5. That would be A. A is the value of the first term. And it ends with 700. That would be the value of the last term. So we know T100, because it's 100 terms, is 700. So we want to find the sum of the first 100 terms. So we want to find S100. And this time, because we know the value of the last term, we can use the second equation. So once again, n over 2, 100 over 2, times A, 5, plus T100, 700. Okay, So we can punch it in our calculator. We get 705 times 50, and we get 35,250. Okay. So, of course, with these equations, we don't always need to just solve for the sum. Sometimes we might know the sum of the series, and we might want to find some other information. And of course, we can do that as long as we have enough information. If any one thing in these equations is unknown, we can rearrange to solve for it. The tricky one would be if we don't know the number of terms n, um, especially in this top version of the equation, but we won't see that for arithmetic. So the sum of the arithmetic series of 52 terms is 2,470. If the first term is -7, find term 52. Okay, so a couple things we can tell here. So it says that it has 52 terms. That's n. The sum is, so we know S52 is 2,470. It says if the first term is -7, A is -7. It wants us to find T52. So we're going to want to use the second version of the equation and plug in for that. So we know that the sum, oh, I'm writing the wrong numbers here, 2,470 is equal to n over 2, 52 over 2, times A plus T52. And we don't know what T52 is, but that's what we want to find. So we're going to have to rearrange and solve for T52. So if we want to move a fraction that's multiplying over to the other side, we just flip it and multiply it on the other side. So we're going to get 2 over 52 times 2,470 equals -7 plus T52. Okay. And we can multiply that out there. Take our calculator, 2 times 2470. Divide by 52. Equal to 95. And then if we want to get the -7 over, we'll just add it onto the other side. Plus 7 is equal to T52. And we'll get that T52 is 95 plus 7, or 102. All right. So in your practice, you'll be solving for some other things as well, like you might want to solve for the first term, things like that. But before you do that, let's take a look at geometric series. So recall that arithmetic, there's a constant difference between each term, and in geometric, there is a constant ratio between each term. So this is the equation for the sum of the first n terms, Sn equals A times r to the power of n minus 1. Now, one really important thing to note, we're not quite done, but this minus 1 is not in the exponent. It is in the base. Okay, so when we plug in for this, we're going to do something to the power of n. It equals on our calculator, and then go minus 1. And this is all over r minus 1. Okay, there's only one equation for this. There's no equation using t of n for geometric series. Let's take a look at our first example. So for this series here, find S11. It should say dot, 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 but it just says dot. It keeps going. Okay, so let's see. What can we tell from this? Well, we know the value of the first term. A is -1. R, well, what's happening here is it went from -1 to 2 to -4 to +8. So the sign's changing each time. I think that means that we have a negative multiplier. It looks like we're multiplying by -2. And lastly, we know n. N is 11 because we want to find the sum of the first 11 terms. So let's find that. S11 is equal to A, -1, times R, power of 11. Now recall, when you're doing negative bases with exponents on your calculator, it can be a little tricky. You got to be careful. So maybe we'll just put brackets around that. And minus 1, all divided by R, -2 minus 1. Okay. So I'll do this in a few steps here just to kind of show the process in more detail. Eventually you can kind of do this in your calculator, but we'll go through the process this time. So we have to do bed mass here. Now, we can do what we can to the top of the equation, we can do what we can to the bottom of the equation. So on the bottom, it looks pretty simple. So negative 2 minus 1, that's negative 3. On the top here, though, we have to deal with the inner bracket first, and we have to deal with the exponent before we can even do that. So negative 2 to the power of 11. So we got a negative 1 up front. Negative 2 to the power of 11. Take out our calculators. That is negative 2,048. And then we want to subtract 1 from that. Okay. I have to go up here. Okay, so we get negative 1 times negative, do that subtraction, 2049 all over 3. And now at this point, I think I can plug it in my calculator. Do the multiplication on the top, divide by negative 3, and I get negative 680. Okay. Okay, so let's try this next one. So it says find the first term. So I'm going to write right away here. It wants us to find A. A is the thing we're trying to find. That's unusual. So of a 3-term series, n is 3, with a sum of 37. Okay, so the sum, S3, is 37. Where each term triples the previous. Triples. So, if it's tripling each time, then R is 3. Okay, so I think we know enough here. We only have one thing we don't know. That's always a good sign. So let's plug that in. So we're going to get 37 equals A. We don't know A. R, 3, to the power of n, 3, minus 1. All over R minus 1. So 3 minus 1. Okay, so let's work on simplifying this into a nice fraction first, and then we'll go from there. So we get 37 equals A. On the top here, we're going to get 3 to the cubed. That's 27 minus 1. So we're going to get a 26 over 3 minus 1, 2. Okay, so we'll multiply the 2 up, divide by 26. We'll get A is 74 over 26. And we'll simplify that fraction. That's not too ridiculous to simplify. Everything's divisible by 2. Get 37 over 13. Right, the value of the first term. Okay, let's try another one here. So it says find the sum of the first 5 terms of this series. 1/2 plus 1/4 plus 1/8. And then I guess the next one will be plus a 16th plus 1 over 32 plus 1 over 64, etc. So it is halving each time. And it can be a little tricky to see that because the denominator's doubling each time. But in order to do that as multiplication, we'd have to multiply R by 1/2. So we multiply by 1 over 2. We can also write this as 0.5. As long as our fraction is a very nice decimal, when we're doing our calculations, you can sometimes use a decimal, I guess. Okay, so A, our first term, is also 1/2, or 0.5. And it tells us n is 5. So we want to find the sum of the first 5 terms is A 0.5 times 0.5 to the power of n, 5 minus 1, all divide by R, 0.5 minus 1. Okay, so I think this is something we can punch in our calculator all at once. Now, you do have to be a little careful. You're going to want to do the entire, so we're going to want to do it in bed mass. We'll do the whole top first. So I'm going to do 0.5 to the power of 5 equals minus 1 equals times 0.5. Okay, so that's the top. And I have some decimal. I'm not going to write down that decimal, though. I'm going to divide by, and then I'm going to put the bottom of brackets, divide by 0.5 minus 1. Close bracket. I get 0.96875. And if you're fortunate like me, you may have a fraction button on your calculator. Some calculators, will automatically put in fraction. Some of them have like this SD button. It's like with an arrow between them, and you can click that and it'll switch. Some calculators like mine, they have a button on the left side that says A and then B over C. And then if you hit shift and you hit that button, it does it as a non-mixed fraction. And this is a 31 over 32. Okay. So it also wants us to find S10. Find this in a different color. So same thing. The only difference here is N is 10. So S10 is 0.5 to the power of 10 minus 1, 0.5 minus 1. All right. So I'll punch in our calculators again. I'm not going to talk through it like I did last time. I think this is a good exercise for you to try to make sure you know how to do it on your own. I get 0.99902 dot dot dot. Okay. If I hit that fraction button, this is 1023 over 124. Okay. So one of the interesting properties, this is actually a important in mathematics series, interesting property is as we keep going, if we say like found S20, we'd get a number even closer to 1. And if we got S100, we'd get a number even closer to 1. And this is a series where if you added up infinitely many terms of it, you would get closer and closer to 1 without approaching. And it's kind of like an asymptote or a limit on how close you can get. And it's very related to some of the stuff we did with exponentials or the reciprocal function before in the course. All right, that is it for the lesson.